Good day everyone. So in this video we will gonna discuss the length calculations to come up with the general heat conduction equation in rectangular coordinates. Recall last time that we based our concept or the calculation regarding the uh, energy balance that is going in and out on this system. So if we will gonna study the say this is our medium, a solid medium, and if we're gonna take some element, okay, so this is our element, and we will gonna do some energy balance on this on this element for us to have the energy that is going out or entering, and the energy that's the energy that's going in and out on the system. Okay, so say if we have this element, then since we are talking about the space, then let me have our coordinate system. Say this is the x direction, and going there is our y, and going upward is our z. So this is our xyz axis, and it is based of course in our right hand rule, right? So if we have this element now, then we can now do the analysis of our energy balance. So we have, say, for our x, if this is our positive direction, so for energy entering our element or this system, we have this, and let's represent this as qx. So from x, and we have the energy that is going out, the heat heat that is going out on the system, and let's call it x plus dx. Since from this point here, then if we take the smallest interval during the time t, then this part here we can call it as d of x, right? So if you take this smallest strip of this element, then we can call it as the dx. Okay, so this part here is our dx. From x up to this point is our dx. So we can call our heat that is leaving the system as the q dot x plus dx. Okay. We use this q dot because we are dealing with time interval t. Okay, so this is for our qx. Then how about for the same, how about for the heat that is going in and out on y direction? So we have going in, and we call it qy. Then we have the heat that is going out on the y direction. So since this is our uh, y, then after this smallest time interval, this length here is our dy. So we have y plus dy. Okay, and same principle, we're gonna do the analysis of q going in and out on this element at z direction. So we have this going up here, so we have qz going to this direction, and our q leaving is qz plus dz. Okay, so that is for the heat entering and leaving this system. Okay, having this illustration or figure, let's now apply our balance and um, have the energy in and energy out. Okay, so our Q that is entering the system is, we have this part here. So we have Qx, and we have this Qy plus, of course, the heat that is going or entering at z direction. So we have the q at x, at y, and z direction. So they are all going into the system. So let's now equate this to our energy or heat going out on the system. So this is based on our energy balance. So this is our energy balance. So our Q that is going out is that we have, so at the x direction, we have this part. So we have Q x plus dx. And on the right, we have this part, right? So we have plus Q y plus dy. And lastly, we have this term, plus Q z plus dz. So all in all, in terms of our heat entering and leaving the system, we have this balance. We have the Q in is equal to our Q out. Okay? Okay. Okay. So aside from this heat, we also have another energy that is involved in our system. Okay, like what we have discussed last time, we have some we can have some heat generation inside on our system. So say we have some, say let's call it G, because on our medium, or in this uh, element, we can have some heat that is being generated. So we have the this term, we have G dot. Okay, so this is the total heat generation in the given medium or volume. Okay, so we have G dot. So we will gonna add this in our energy in. So let me write it first. So we have Q plus Y plus Z plus, because there is a phenomenon or time that it can have a certain heat that can be generated. So we have G dot, okay, equals to this part. Okay, and aside from this, we can also have some energy that cannot leave the system. And since cannot leave the system, uh, it is somehow being stored in the system. So we have, let's call it energy stored. So let's have some plus energy stored. Okay, so all in all, we have this total balance of our system. So we have energy in is equal to our energy out. Again, we have the heat going in the system, and we have these terms of heat that is going out on the system. But there are also some heat that is being generated, so we call it G dot, and there is also some energy that is being stored on this element or on this medium. Okay, so we need to consider this, and we need to add the energy stored here in our equation. So all in all, we have this balance. Our heat plus the heat generation is equal to the heat leaving plus the energy stored. Okay. Once again, we have this final balance, and let us always remember that this balance on this element is expressed during a small time interval. So that's why we have this symbol that here to express that it is in in a certain rate basis or in certain time interval basis. Okay, so let me rewrite it. We have Q X Q Y plus Q Z plus our heat generation, or yes, the total heat generation in a medium of certain volume, and we have our uh, heat that is living in the system at X, Y, and Z direction. And then lastly, we have our energy that is stored in the system. Okay, so on the next video we will gonna um, discuss it furthermore on how we can arrive on the general heat conduction equation. So see you on our next video.